Have you ever tried looking into AI tools recently and just felt completely overwhelmed by acronyms like LangChain, LangGraph, MCP, and n8n? It feels like a storm of buzzwords constantly flying at you. This diagram is our smart factory blueprint. Instead of writing code, we will map the entire AI ecosystem so you know exactly what tools you need. It breaks down into 5 zones: the model, user interface, communication protocols, server, and external data. We are going to start right in the middle with what we call the orchestration layer. Think of this as the foreman of your factory. The foreman's job is to take your instructions and figure out exactly who needs to do what. Without a good foreman, even the smartest AI model is just an isolated brain sitting in a jar. It can't actually do anything with your real-world tasks. That is why picking the right foreman is the most critical first step. Let's look at our first option, n8n. Imagine a completely visual, no-code assembly line. If your main goal is moving data around, like grabbing customer emails and automatically putting them into a spreadsheet, n8n is perfect. You don't need to be a programmer to use it. Then we have LangChain. This is more like a bucket of bricks for programmers. It gives you standardized pieces to write custom AI scripts. If your task is a simple straight line, it works great. But if you try to build something really complicated, the code can get messy and hard to fix. This diagram shows our third option, LangGraph. Think of it as a city traffic system with red lights and intersections. If your AI makes a mistake, LangGraph sends it back to try again, taking an alternate route. It handles complex loops and corrections. This table compares our 3 foremans side by side. n8n is highly visual and beginner-friendly. LangChain requires coding and is best for straightforward tasks. LangGraph requires the most coding skill, but it handles those complex looping tasks. The tool you pick now determines how much work you'll have to do later. Using a simple assembly line for a complex city-sized project often leads to tangled logic that is difficult to manage as your project grows. Now, looking back at our map, let's focus on a big question. AI models, at their core, just spit out text. So how do they actually reach out and open a file on your computer? It starts with an ability called function calling. Instead of just generating a text answer, the AI can generate a specific request, basically saying, I need to use a tool to search the web right now. That request is answered by the server. Think of this as a small helper program that stands up and says, I have a tool for searching the web, and I have a tool for reading your database. This bridge is what finally breaks the wall between chatting and doing. It gives the AI a pair of hands so it can safely reach out, pull in real-world data, and actually execute actions. Now that the AI has hands, it needs a nervous system to send signals from its brain to its fingers. Depending on how far the signal needs to travel, we use different communication methods. The first is HTTP. Think of this like sending a letter through the mail. You send a request out to a distant server in the cloud, and you wait for a package to come back. It's reliable, but there is a slight delay. The second is SSE. Imagine tuning into a live radio broadcast. Instead of waiting for one big package, the data flows to you continuously in one direction, streaming the information in real time. The third is direct talk. This is like sitting face-to-face in the same room. It is used when the AI and the tools are on the exact same computer, allowing for instant, zero-delay conversation. Sometimes your AI is in the cloud, but your tools are on your local laptop. In those cases, we use secure internet tunnels, like a private intercom line, to safely bridge the gap between your local apps and the cloud. The speed of this nervous system dictates how fast your AI can react. If you pick a slow connection for a task that requires hundreds of fast actions, your entire system will start to stutter and lag. With our hands and our nervous system in place, we arrive at the very front of our factory, the user interface. This is where you actually sit down and command the AI. For coding, one popular interface is Cursor. Using Cursor feels like stepping into a highly advanced mechanical suit. It wraps around your code, predicts what you want to type next, and acts as a direct extension of your own thoughts. Another approach is using a plugin like Clayline. This is more like hiring a dedicated digital intern. You hand the intern a very specific list of rules on a clipboard, and they go off to work on their own while you supervise. Your choice of interface decides your role in the process. You have to decide if you want to be the pilot steering the machine directly or the manager handing out tasks to an assistant. Warning tone. Before you start building, there is a very common financial trap that catches a lot of beginners by surprise. This is the difference between a flat monthly fee and metered billing. On the left, you pay a set price for the month, but on the right, the AI provider charges you for every tiny bit of information the AI handles. If your automation gets stuck in a loop and keeps talking to itself, that meter keeps spinning, and your bill can skyrocket. So, how should you get started? If you are a complete beginner with no coding experience, skip the complex setups. Use visual platforms like Dify or Cozy. You can drag and drop pieces to learn how things work safely. If you need to automate real business tasks, like handling customer emails or moving data between spreadsheets, n8n is your best bet for a sturdy, reliable assembly line. And if you're an experienced developer looking to build a team of highly capable AI assistants, use Cursor to write the code, LangGraph to manage the complex loops, and a local server connection to give your AI access to your files. Building with AI doesn't have to be overwhelming. When you understand the map, the jargon fades away, and you can pick exactly the right tools to build your own smart factory.